Hello everyone, my name is Susanne Schmidt from the University of Hamburg. I'm very happy to be here today and to share one of our latest projects with you, which is about blended agents. And I think a good starting point to explain this concept of blended agents is to think about the realism of virtual agents in general. So if you think about realism of agents, you may think about their visual appearance. So do they look photorealistic or not? Or you may think about their movements or their behavior. Is it natural? Do they have a natural gazing behavior, or is it more like a robot? Or you may also think about the quality of speech. So is it more like a real speaker or more like artificial, so it feels synthesized? And actually in all of these dimensions of realism, virtual agents became much better in the last few years. So I think it's reasonable to assume then in some years, or at least in some decades, we can achieve results which are very close to recorded humans. So here, for example, you can see that we already have the methods in computer graphics to create results which are very similar to humans. The only thing is that it's not in real time, but I'm pretty sure that we can achieve this in a couple of years. So somehow we could assume, okay, in some years we have a perfect copy of a real human, but I would argue that's not the case, because there are still some differences between virtual agents and our real humans. And one of these differences is when you leave a virtual environment as a user, usually not only the virtual agent is disappearing, but also everything the virtual agent did in the virtual environment. So every proof of existence of this virtual agent just disappears when the user is removing his headset or if he's leaving a cave, for example. And the reason for that is that we have an asymmetry between real interaction partners and virtual interaction partners. So real interaction partners usually can influence both physical and virtual objects. So, for example, virtual objects by using tracking systems or sensing technology. But on the other hand, virtual agents usually can only influence virtual objects. So it's much harder to implement interaction between a virtual agent and a physical object. And with the concept of blended agents, we want to fill this gap between the virtual and the real world. So we define blended agents as agents that are capable of changing properties of real-world objects. And actually there are only a few examples of similar concepts. Two of them are on this slide, and actually both of them are from the group of our session chair, Greg Welch. So here you can see two examples of virtual physical interactions. The first one is the wobbly table, and the second one, the physical virtual table. And in both cases, the virtual agent was able to change the position or the pose of a real physical object. So on the left example, it was the table itself. And in the second one, it was a small token, a physical token, which was used in the context of a tabletop game. And in our project, we want to extend this work by introducing a second form of virtual physical interactions. So these interactions were focusing on the location of an object, and now we want to introduce interactions which are focusing on the surface material of such objects. And we do this because we think that if a virtual agent could change the surface material of an object, then we could have a change which also persists when the virtual experience is over. So, for example, if he could write on a real piece of paper and this is persistent, then a user could take this piece of paper out of the virtual environment, and we think that this could add a new quality to virtual agents. So, these are the two forms we wanted to consider in our experiments, so we wanted to compare them, and therefore we implemented two setups. The first one was a robotic ball, and the second one a thermal table. And I want to show you very shortly how these prototypic setups looked like, so you can imagine how they worked in our experiment. First, the robotic ball. This was something we didn't invent ourselves. It's a Sphero Mini. So this is a robotic ball with an outer shell, and in the shell there is a weight which is motorized. So by moving the weight, you can create a weight shift, and therefore the entire ball is moving on a ground plane. The contribution in this case was that we implemented a JavaScript API, so it is now able we are now able to send controls from a Unity application in order to synchronize the physical movement of this ball with, for example, the animation of a virtual agent. The second prototype we built was a little bit more of engineering work, so we wanted to find a material which is affected by external stimuli, and we tested a lot of different smart materials which were sensitive to temperature, to UV light, also to fluids. And in the end, we decided to use thermochromic ink, which is an ink that is invisible if you heat it up above a specific activation temperature. In our case, it was 47 degrees Celsius. And if you cool it down again, then it gets visible. And in this case, we used a Peltier element, so you can see it here. It's right below the surface of the thermal table. And via a microprocessor, we can change the polarity of this Peltier element so that it both can heat up or cool down. And the idea of the setup was that you have to prepare a sheet of paper with something written on it with thermochromic ink. Then you can heat it up so it gets invisible. And during the experience, when the virtual agent is writing something, we cool down the Peltier element, and therefore this writing gets visible again. So you can already see that there is a limitation, because in this case now we have to prepare the writing. Otherwise we cannot make it invisible again, but I will talk a little bit more about this at the end of the talk. So we have some ideas to change this, but this was a first proof of concept. And now we wanted to compare both forms of virtual physical interactions, so we conducted a user study. And for this user study, we invited 40 participants to play a mini-golf match against a virtual or blended agent. It was a little bit of a tough decision if we want to use a within or between subjects design. In the end, we chose a between subjects design because we think that if you have a direct comparison between a virtual agent without any virtual physical capabilities and a blended agent, then the results will always be biased. So we used the between subject designs, although we know with 40 participants it's more like a preliminary study, because for final results we would need more than 100 participants. We designed the study with 4 different conditions. So we had these 2 prototypes, the robotic ball and the thermal table, and with these we could have a golf ball which is physical or virtual, and we could have handwriting which is virtual or persistent. When the participant entered the virtual environment, in this case it was a cave, he first saw a mini golf course, and this was also physical. So we had physical obstacles, a physical hole, and also the participant was playing with a real golf ball and a real golf club. And then he prepared a scorecard on the thermal table. So he came into the room, there was this thermal table with an empty sheet of paper on top, and together with the experimenter, a scorecard was prepared, so a table with the names on it and blank spaces for the scores. So the user could see that in the beginning there was nothing on this paper. Afterwards we had different rounds. Sometimes the participant was playing, sometimes the agent, and here you can see a condition with a blended agent. So in this case the agent was playing with a real golf ball, and we used motion capturing to have animations which are synchronized with the predefined path of the physical ball. When the virtual agent put the ball into the hole, he then went to the thermal table, and he first wrote the score virtually. So we wanted to do this because, you can see it here, we wanted to have the writing animation path. So not only the end result, but we wanted to have a smooth animation. So first the score was virtual, and after some time it was replaced by the physical score. So the virtual score faded out and the physical score appeared. So in the end, when the user was leaving the cave, the virtual environment, if he had this condition with physical writing, he could take the scorecard and still see the score. After this experiment, we measured different things. So we had some observational data, but we also asked the participants to fill in some questionnaires regarding social presence, spatial presence, and also ecological validity, engagement. I just have 2 examples here, but I think they are quite representative for all of the questionnaires, because as you can see, the results are very similar for all of the 4 conditions. So actually we couldn't find significant main or interaction effects for these 5 subjective measures. And somehow this was of course not expected, so we thought that there will be a difference. And what was also strange for us is that we had additional open questions in the end, and in these questions the users who experienced physical handwriting or also the physical ball were very enthusiastic about the experience. So they said, okay, it was very memorable, it was more meaningful than without the physical handwriting. We were very surprised, and many of them also mentioned that it made the virtual agent more realistic. But in the so this is not matching the subjective response in the questionnaire. And of course we were wondering, why is this the case? And we have different aspects discussed in the paper. One thing is that maybe you saw in this diagram, there are some ceiling effects. So for example, for engagement, we already have scores which are very close to the maximum. But one thing I think is very important is the expectations of users. So do users expect virtual agents to have physical virtual capabilities? And I think the answer is no. Users don't expect this. So none of our participants experienced something before which was similar. So usually they experienced virtual agents which are only capable of influencing virtual objects. So they don't expect that. And this was also shown during the experiment, because some of the participants even tried to fill in the score for the virtual agent because they assumed he cannot do it himself, so I have to help. And out of the 20 participants who experienced the physical handwriting, only 7 even noticed that the handwriting was persistent. So 13 of them took the scorecard, went out of the cave, and then they didn't notice that the score was still there. So we asked them afterwards, and then they were super surprised and said, oh, it's super cool, but during the experience they didn't notice it at all because they didn't expect it. And I think if you don't expect this, then if it's not there, you don't rate it worse than if it's there. So this may be a difference to within subject design, because there you have the direct comparison, but for between subject design you don't have. So for future work, we want to do follow-up studies. I know that you always have to tell that you do some follow-up studies, but in this case we really want to do it because of course we see that there is potential. We got a lot of positive feedback, but we couldn't show any differences. So what we want to do, we want to measure objective things. So we did it a little bit in the first study, but now we want to focus more on it. So like the gazing behavior of users. So we already observed that users seem to focus more on the virtual agent if he has some virtual physical capabilities. We also want to change the scales of the questionnaires a little bit. So what we observed is that usually when we had a scale from 1 to 5, For the realism of an agent, for example, people wrote in the open question like, this was much better than any agent I experienced, 4 out of 5. And then we had others who said like, it was better than a robot, 4 out of 5. So it was quite similar. And we think that maybe if we have a higher granularity in these scales, then maybe the responses are more meaningful to us. And the last thing we want to change is to make the interactions a little bit more meaningful. So in this case, the scorecard could be taken home as a souvenir. So this was suggested to the users, but they couldn't use it afterwards. So maybe if you have like a map and the virtual agent is showing you the directions to a specific place, then this might be more useful. And also, then it's not only interesting when you experience it the first time, but also for the second, third, and the fourth time. So this is something we want to work on. And the second thing we are currently working on, which is maybe not super scientific, but we really want to have a thermal table which is interactive. So this was a huge limitation that we always have to prepare the score before we can show it. And now we are working on an extended CNC machine, so you can really write something during the experience, and I think this adds a lot of quality if you can say, hey, my name is Susanne, and then he's just writing it in real time. I think this would be a nice thing to have, and this is why we want to do it now. And this is what we plan for the future. So thank you a lot for your attention, and if you have any questions, I'm happy to answer them.
It's so stimulating. I really enjoy it, and I have questions. Sorry.
Thanks
for everybody. What is? I've been working with connoisseurs versus naive people in VR, and there's a big difference in VR. I think the overwhelming experience of just being in the cave for some people might be why your result potentially is, can be skewed. Have you tracked experience of your test subjects?
We didn't track it, although we excluded everyone who was working in our group or in the context of our group, because we think that this would change the results completely. So we only asked students or visitors from other groups, and most of them experienced it for like first to third time, I think. So they were not regular users of virtual reality applications. But you're right. What I was a little bit surprised of that even when we tested it before with our group members, they were really excited. So even for them it was something new and they didn't expect it. But you're right that maybe it would make sense in the future study to also track that. So how is the experience level of those participants?
Yeah. Just a novelty of it.
Yeah.
What a lot of people are thrown off with the regular VR with the game I would imagine.
Yeah. Thanks for the question.
Beautiful work. So I have a question. I might have missed that. When during the experiment, when the agent was manipulating the real golf or versus virtual golf, is the human participant the same, like playing a virtual or real?
Actually, the participant was always playing with a physical golf ball, but this was also something interesting. Maybe it would be a different result if you have like a shared interaction space, so that the virtual agent is using the same object as the real user in this case. It was just a little bit difficult to implement, so we thought about it, but we really think that these robotic balls are not made for using them for playing. But maybe the other way around would be interesting, that the participant is also using a virtual ball. And yes, good question.
Yeah, thank you.
So another way to do the writing would have been with a tablet, right? And you could make that sort of interactive. The user could write and the virtual agent could write. Do you think that would sort of suffice as an interactive component, or do you think that the physical writing where it seems magical is better?
We had a lot of discussions about this. My personal opinion is that it makes a huge difference if you can see the technology or if the technology is hidden from the user. So I think for helping users, so for example, if the virtual agent is working in a tourism center and helping the visitors, a tablet would work as well. And I think for some applications this is also the future, because you can just maybe also take your own smartphone and get the directions on your own personal device. But I think for having this additional realism of virtual agents, it helps that you don't see the technology at all, so that it's hidden from the user.
Thanks.
Related to that, I like that you said something at the beginning, the physical aspect of like that persists beyond that experience. So the fact that you walk away with a piece of paper that you can fold up and put in your pocket and take out later. I think it'd be really interesting to do experiments that look at the effect on people after that experience. It's somehow something that happens persists, like encouragement or something like that. Does that help them do a task better later because they have this certificate with the name on it?
No.
Something like that makes them feel proud, feels real.
Actually, many of the participants of the physical handwriting condition took the scorecard home, although it didn't have any value, I think, but many of them did it, and I think this is a good sign, actually.